Hi, I'm Gabe Venegas. I'm a grad student here at UT studying sediment acoustics. I went on a pilot study off the coast of Martha's Vineyard in the New England mud patch, where there contains one of the largest basically patches of mud in the ocean bottom that's accessible to the United States coast. So it's great for conducting sediment characterization surveys as well as propagation experiments to better understand how sound interacts with a mud bottom. In the past, there's been a lot of interest in sandy bottoms. Now we're shifting more toward muddy bottoms. That's interesting because the sound speed of mud is quite variable, and it's very close to the sound speed of the water. So you get a lot of sound trapped in the ocean bottom, and sometimes you get phase inversion of the reflected sound. And since it's so variable, we're trying to quantify the acoustic properties of mud bottoms. This is a survey cruise to collect cores and test their properties so that the following year there could be a propagation experiment. A core is essentially a sample of the sediment. It can be extracted in various different ways using a gravity core, which is basically a very heavy weight connected to a cylindrical tube. In that cylindrical tube there contains a core liner. From a winch you drop it into the ocean bottom. On the very end of the core there's a core catcher, which allows sediment to go in but not out. Then that core is brought back to the ship. The core liner is then removed from the large metal gravity core, and then it's sectioned and analyzed later. From the cores we can measure porosity, permeability, impressional sound speed and attenuation, shear sound speed and attenuation, conductivity. We essentially went out and cored at several locations and processed the cores on ship as far as grain size analysis, compressional sound speed and attenuation, shear sound speed and attenuation at several different frequencies. Back in World War II, sonar was mainly used in the deep ocean, while now we're more interested in port protection and patrol along the continental shelf, which is primarily shallow water. As the ocean depth becomes smaller, we have to pay more attention to the reflections from both the top and bottom boundary conditions. I'm clearly interested in the sound interaction between the ocean and the ocean bottom. For more information about this project and other acoustics-related projects at UT, please visit the Texas Acoustics website, and thanks for watching.